Hello everyone, I am back with one more video, and this time the video is related to the numericals which are in the third part of the first chapter for class 9 ICSE Physics Selena publications. The third part of the chapter is related to simple pendulum, and just a reminder, there are two basic formulas with the help of which we are going to solve or discuss the numericals today. First formula is T equals to 2 pi square root of L by G, where T stands for time period of a simple pendulum, L is the effective length of the pendulum, and G is the acceleration due to gravity. And there is one more simple formula, that is the relation between time period and frequency of a simple pendulum. So time period equals to 1 by F, or F equals to 1 by T. So with the help of these two formulas, we are going to discuss the numericals today. If you are having a Selena publication with you, then you can take out page number 28 of your book with the latest publication, means that is for the year 2026. You will get the numericals on page number 28. Okay, so first part of the question, a simple pendulum completes 40 oscillations in 1 minute. A simple pendulum completes 40 oscillations in 1 minute. So in 1 minute, number of oscillations completed, number of oscillations completed, that is equals to 40. Now the first part of the sum is asking us frequency. So if you can recall the definition of frequency, what is frequency? Frequency means the number of oscillations completed in 1 second. So in 1 minute means 60 minutes, 60 seconds. So one second in 1 second, number of oscillations completed, can we write it as 40 by 60, because 60 minute means 1 minute means 60 seconds, so we can write it as 40 by 60. So we get it as 2 by 3, 2 by 3. And now since we are finding the frequency, so frequency's units is, we can write it as hertz or per second. Why per second? Per second because frequency is 1 by time period and SI unit of time period is second. So here approximate value 2 by 3 means, in if you find it in decimal, approximate value we are going to get it as 0.67 per second as the unit, or hertz. Number B. Number B, they have asked us to find the time period. So time period, obviously again we are going to use this formula 1 by F, or 1 by, now I am not going to use the value 0.67 because it's already in decimal. For me it is easy to choose the fractional value, that is 2 by 3. So 1 by 2 by 3 will become 3 by 2, and since we are calculating the time period, we can write the unit as second. So we will get it as 1.5 second. So 1.5 second is the time period. Let's move on to question number 2. So question number 2 is telling the time period of a simple pendulum is 2 seconds. What is its frequency? Given time period is 2 seconds, we can find out the frequency using the formula F equals to 1 by T. So 1 by 2, and since again we are finding the frequency, our unit is going to be per second. So I can write 0.5 per second, right? So this was related to the first part of the question. Second part of the question is asking us what name is given to such a pendulum. Please remember, this is in the theory part of the chapter, that whenever a simple pendulum is having a time period of 2 seconds, such a pendulum is known as seconds pendulum. Such a pendulum, such a pendulum is known as seconds pendulum. Why seconds pendulum? Because its time period is 2 seconds. We are going to discuss it further in the upcoming questions. Okay. So now we will move on to question number 3. I'll erase the board for the convenience. Okay. Question number 3. So question number 3, a second pendulum is taken to a place where acceleration due to gravity falls to 1/4. A second pendulum is taken. So whenever we are getting a question where they have mentioned second pendulum, let us first write given time period of the second pendulum is 2 seconds, right? Now it's said that acceleration due to gravity falls to 1/4, 1/4 maybe of the original value. Okay, how is the time period affected, if at all? So as we can recall the formula, T is equals to 2 pi square root of L over G, right? So from here we can conclude that time period is inversely proportional to the square root of G. Now the question is, how is the time period going to get affected if acceleration due to gravity becomes 1/4? So if acceleration due to gravity is becoming 1/4 of the original one, right, then how is the time period going to change? We know time period is going to change because in the formula they are inversely related. So question is, if at all, give reason, and then what will be its new time period. So we can first state that time period is going to get affected, is going to get affected as time period is inversely proportional to the square root of G, right? Now question is how, means what will be its new time period. So if the original acceleration due to gravity, acceleration due to gravity is G, right? Acceleration due to gravity is G. Now new acceleration due to gravity is falling to 1/4, right? New acceleration due to gravity is 1/4, is 1/4 of the original one. So therefore I can simply write new time period, new time period, that is I can write it as, say, T1 is going to be proportional to the square root of 1 by 4 G, right? To the square root of 1 by 4. So here if we do this, 1 by 4 here, because value of G is in the numerator, so this is going to be in the, sorry, denominator, it's going to be in the denominator. So from here we can write that T1 is proportional, T1 is proportional to, I can write here as, say, 4G, right? Square root of 4, that is, I can also mention this as T1, T1 is proportional to square root of 4 means 2, and this remains in the, denominator, this remains in the denominator. So 2 and multiply by 1 by root over G, which is, we can say that time period is proportional to 2 multiply by what was here, 1 by root over G, that is the original time period, where T is the original time period. So what will be its new time period? Its new time period is going to get doubled. So we can conclude that its new time period, will be double the original one, double than the original one, double than the original one. Okay, so you can do it in this way. I think this is the best way to showcase. So before I move on to the next one, again I'll just summarize this question. First is, how will its time period affected? So time period is going to get affected, in bracket please write, it's going, since we are seeing that in the new time period is getting doubled, so I can simply write it as it is increasing. Okay, it is increasing. Then The question is give reason. So give reason, we have already mentioned the reason as t is proportional to 1 by square root of g. And then third part is showing what will be the new time period. So new time period we are getting as the double than the original one. I hope this sum is clear. If you are having any doubt regarding this, you can use the comment section. I'll surely try to help out. So we'll move on to the fourth one. Fourth question. Fourth question, find the length of a seconds pendulum. Again, they have mentioned seconds pendulum. So the first thing before moving on to the question, I'll write time period equals to 2 seconds. So we have to find the length of second pendulum at a place where the value of g is given as 10 meter per second square, right? 10 meter per second square, and the value of pi is also given. The value of pi is also given as 3.14. So since the value of pi is given 3.14, we are not supposed to use the fractional value, that is 22 by 7. Okay, and we are asked to find the length. Length means the effective length of a simple pendulum. So we know this formula, 2 pi square root of L by G. From here, from this formula, first thing that we have to find the value of L. So what we are going to do is that T by 2 pi, right? T by 2 pi equals to square root of L by G. From here, squaring both sides, we will be easily getting T square by 4 pi square equals to L by G. Now from here I can conclude that L equals to G will shift this side. So T square G by 4 pi square. Now you see we have got our formula, that is effective length of the pendulum equals to T square G by 4 pi square. So now what do we need to do? We have got all the values. We are just going to place the values and calculate. So T square means 4. G has got the value of 10. G has got a value of 10. Then again here 4 we have, and then we have pi square, that is 3.14 into 3.14, since there is a square. Now please check the calculation. 4 and 4 easily gets cancelled. So we have got 10 by 3.14 whole square. You can do the calculation. You must be, means you have to do it manually. Please do not use any sort of any calculator. Since there is a decimal point here, I can just show you a glimpse of how to calculate in a easy way manually. um, 10, here we have two places of decimal, two places of decimal, so total four place of decimal. So we already have got a 10 in the numerator, right? So four place of decimal, I am adding the four zeros in the numerator, and then you can calculate 314 into 314, right? Then you can use you can directly multiply and do the division, or if you want to use the crisscross method, it's your choice. So we are going to get an approximate value of the effective length here. So that is going to be here 1 point in, as per your book it is 1.0142. Okay, 1.0142 meter. So you can cross check the calculation. If there is anything wrong, please use the comment section and let me know. So this is it for sum number 4. Number 5, sum number 5. For number 5, they have said compare the time period of two pendulum of length 1 meter and 9 meter. So L1 is given as 1 meter and L2 is given as 9 meter, and they have asked us to compare the time periods. That means we have to find the ratio of T1 is to T2. So for this, first we need to remember that T is proportional to square root of L. T is proportional to square root of L. So therefore T1 is to T2 is going to be is going to be proportional to root over L1. Root over L1 is to root over L2, right? So we can simply write it as 1 by 9 over root. Okay, so we are going to get it as 1 is to 3. So we are going to get that time period, that is the ratio of the time periods are 1 is to 3. So this is it for sum number 5. We have 4 more sums remaining. I'll erase number 4. Please use the comment section to give your valuable feedback. That will help my channel to grow. So we are going to resume with number 6. So 6, it is said a pendulum completes 2 oscillations in 5 seconds. A pendulum completes 2 oscillations in 5 seconds. So in 5 seconds, number of oscillations completed, number of oscillations completed equals to 2, and the question is, that is the question is find its time period. So in order to calculate the time period, first we need to calculate its frequency. Can I just write in 1 second number of oscillations completed 2 by 5, or we can write it as 0.4, 0.4 per second, right? 0.4 per second. Why? Because this is the frequency. Or directly I can write f equals to 0.4 per second. Now the first part of the question, they have asked us the time period. So time period equals to 1 by f, or we can, I'll just use the fractional value 2 by 5 or 5 by 2 seconds. So 2.5 seconds is the time period. So 2.5 seconds, this is number 6. Number 6 part A, 2.5 seconds is the time period. Now for number B, the value of G is given 9.8 meter per second square. Value of G is given as 9.8 meter per second square, and again we have to find its effective length. So effective length, if you can recall the formula, if you don't recall the formula, again I'm going to show you the trick. T equals to 2 pi square root of L by G, or we can write it as T square by 4 pi square. 4 pi square equals to L by G. So from here we are getting T square G by 4 pi square. So this is the formula for finding the effective length of the pendulum. And we have got all the values. We have got the time period as 2.5. 2.5 into 2.5 will be 6.25. So I'm directly writing 6.25. You may show the calculation. Value of G is given to us as 9.8. 4 into pi's value, since here in the question it is not given, so for your convenience you may use 22 by 7, or you may use 3.14 whole square. So if you just do the calculations, you will get its effective length. You will get its effective length to be 1.55 meter. 1.55 meter. You just need to do the calculation, but please do not use any calculator, because till class 10 no scientific calculators or even general calculators are allowed in the board exams. So this is it for number 6. Now we will move on to number 7. Number 7. Okay, I'm going to erase this part of the previous question. Number 7, they have given us the ratio of the time periods, that is 2 is to 1. So the ratio of the time period is 2 is to 1, and they are asking us the ratio of the effective length. So to find the ratio of the effective length, we must remember the relation, that is L1 by L2, or I need to find L1 is to L2, right? So I can simply write T1 square by T2 square is equals to L1 by L2, right? So the required ratio, therefore required ratio What is the ratio that we need to find? The ratio of the effective lengths will be T1 square is to T2 square. T1 square is to T2 square. So we can simply write 2 square is to 1 square. So we are going to get 4 is to 1 as our answer. So this is it for number 7. 4 is to 1. Okay, I'll erase this part and we will move on to question number 8. Question number 8. It takes 0.2 seconds for a pendulum bob to move from mean position to one end. Now please think of a simple pendulum. This is the bob. This is its mean position where the bob is actually at rest, and it is said that it is taking how many seconds? It is taking zero point 0.2 seconds. It is taking 0.2 seconds to reach to one of its extreme position. So they have asked what is its time period. Now time period is the time taken to complete one oscillation, and it is very important in this part to understand what do we understand by one oscillation. One oscillation means if the bob is at rest, it is moving from here to here, then it is coming back here and it's not going to stop. So it's also going to travel an equal distance. If we ignore the air resistance, then it is also going to travel almost the equal distance as it has traveled here. So if it is taking 0.2 seconds to go this way, and again it will come here 0.2 seconds, okay, then it is going to move here. So there also the same amount of time we are considering, ignoring the air resistance. So then again coming back to its main position. So now let's calculate its time period. So from here to here 0 0.2, 0 0.2, 0 0.4, 0 0.6 and 0 0.8. So its time period is going to be 0 0.8 seconds. That is the time taken to complete one oscillation. You can write it is the time taken to complete one oscillation. Okay, you may cross check the answer. I'm sure it is 0.8 seconds. Now number 9, the last sum of the chapter. How much time does the bob of a second's pendulum take to move from one extreme of its oscillation to the other extreme? Please remember, for a second's pendulum time period, for a second's pendulum total time period is actually 2 seconds. Okay, now the question given to us is, let the bob be at rest, let it be at this position and at this position. Okay, so the question is how much time will the second's pendulum take from one extreme position. This is an extreme position. This is an extreme position to the other extreme position. So since the time period of a second's pendulum is 2 seconds, 2 seconds means if you have studied from here to here 1 second and from here to here also 1 second. So now the question is how much time will it take from one extreme position to the other extreme position. So since the time period is 2 seconds, please remember 2 seconds means the time taken to complete one oscillation. Now in this case, if I consider the position of an extreme, if the bob is in its extreme position, how will we calculate its oscillation? That is one oscillation. One oscillation means it is going to here, it is going to this side and again getting back to this side, then only we say it is one oscillation. So what will be so total journey from this extreme position to this and again back to this, right? So total time taken here is, as per the definition of the time period, it is 2 seconds. Our question is from one uh, it is going from here and then again to traveling back, then only we say 2 seconds because it's the time period of a second's pendulum. Question is from one extreme position to another one, not again going back to the same extreme. So therefore time taken will be obviously half of this. So the time, or I can simply write the required time taken, because I don't need to write the full statement then. The required time taken is going to be half of the time period. because it's just one extreme position to the other one. It's not getting back to its original position for completing one oscillation. So obviously answer is going to be 1 second, right? So this is it for the last part of the chapter for the numericals. If you are having any doubt, please use the comment section, like, subscribe, and do comment. Constructive comments will be appreciated. Thank you.